Hello and welcome to this video. Today we're going to be talking about our journey to create services that talk to Clickhouse, getting it spun up in Kubernetes. My name is Stephen Rayner. I'm a senior backend engineer with the Applied ML team.
And I'm András Herzog, a backend engineer in the very same team.
So what we tried to do here was spin up a Clickhouse instance inside Kubernetes, set up a few services that can just sort of produce some randomized data and just sort of send data to the Clickhouse instance so we can get from an end-to-end Python and Golang into Clickhouse and then visualized in some other visualization software, which we used Grafana for this, to get an end-to-end experience of how the whole Clickhouse process would work when deployed in Kubernetes in a simplified fashion that we could then take that and export to our existing applications. Problem statement, we needed to move off of Postgres for some of our data because we wanted to get better throughput for some of our analytics. Postgres is a great database. It's wonderful for CRUD-based operations and your standard OLTP kind of things. If you use those terminologies, online transactional processing is what that acronym stands for. And we wanted to move towards more of an analytics database that we could use for getting distributions of model performance, doing analytics, and a series of other things. So for that, we decided to use Clickhouse. Clickhouse has some wonderful benefits in that it is a column-oriented database instead of a row-oriented database, which allows for really, really fast processing of analytics and sort of ad hoc queries. It has an incredibly rich table engine, which we will not be covering in depth in this meeting, which allows you to be incredibly flexible with how you process your queries. And that way, it's very good for that. It is not good as a transactional processing database similar to Postgres. So if you have to do a bunch of updates, Clickhouse is not your jam, wouldn't recommend it for that. There's also a series of really well-supported baked-in functions. So if you find yourself in a space where you are brute forcing a query, there's probably a function. It's probably written about in the docs. One of the things that's great and can be tricky with Clickhouse.
So how we actually iterated? Well, before anything, we did some research. Some part was just some free-form research on our side, reading up on documentation, quick start guides, various table engines, etc., etc. But also we were in a lucky situation that another team in GitLab already started trying to introduce Clickhouse in their project. So we decided to conduct some interviews with them. And these interviews pretty much just were questions. We're trying to explain this video. Why did you go with Clickhouse? What did you do? And what did you find out during the journey?
Yeah, so first steps for this were spinning up a Clickhouse instance on Kubernetes. We leveraged the Altinity Kubernetes operator for this. It makes the whole process significantly easier. Instead of having to maintain all of the Kubernetes manifests, it provides you a templated system which allows you to spin it up yourself. I would highly recommend anyone spinning up Clickhouse on Kubernetes uses that operator as opposed to most any other operation. We did that, and then we decided to spin up very simple services in Python initially to simply just spam data into the data. The standard thing that most people do is they create like a customer tracking data thing and sort of create a standard app that produces customers. That seemed played out and not as much fun as creating a dog tracking app. So we created a table we tried out a number of the different database engines and different table engines to create a database of dogs that tracked things like breed, height, weight, things like this. And then a service that generated random data and just spammed Clickhouse to see if we could hit threshold, hit caps for inserts, which we were able to do. More on that in the documentation attached to the repository. Once we had finished that, we were able to visualize all the data in Grafana using the Clickhouse plugin and a pretty rudimentary knowledge of SQL. So I think if you know some SQL, you can get ahead and handle around your data. And we'll be showing that shortly. And also there's more links in the docs. This is an example dashboard we're going to come back to and talk through how it's got here. Let's start with our Kubernetes manifest. This is the Kubernetes manifest that defines all of the Grafana dashboard and underlying tools you need. There's a config map to define all the plugins we need. We are, of course, leveraging Clickhouse in this demo, so the Clickhouse plugin is in here. That dashboard you saw, we're going to see again in a moment, is related to Clickhouse. Data quality testing. This is a persistent volume claim, which allows you to store data for your Grafana dashboards. Super useful if you want to ever visualize it again. This is the Kubernetes manifest that defines everything you'd ever need about the actual container itself, ports exposed, lifecycle failure probes. Resource limits are currently not fully set because we like that. And this is the service that allows us to visualize and look at the dashboard itself. You can get this set up on your local machine if you connect to a cluster. You'll notice here I am connected to our GKE recommender reviewer cluster. And if I port forward in the appropriate namespace to port 3000, I can now go over here and open localhost 3000 and get Grafana. The data analysis dashboard that I mentioned earlier is probably going to be prominently on the front page. You can jump into it and just scroll through it and take a look at our data quality checks and a bunch of the data checks that this actually came with the Clickhouse plugin for Grafana. You can find all other related things underneath data sources and Clickhouse and dashboards. Those three that came with it. Many of the plugin ecosystem will actually come with default dashboards. If you just want to explore Clickhouse directly via SQL, you can do that by going through the Explore tab on the left here. Jumps into here. I like the SQL editor. You can use a query builder. Pardon me. If you are not a SQL happy person. So let's just do basic stuff. Find all of our tables. There we go. And here's a little demo table that we have that we talked about later, that we talked about in a different video. There you go. That is everything about how to set up and where to find all the information about the POC demo for Clickhouse and our usage of Grafana.
Besides that, we also added persistent volumes because, yeah, you don't want the pod destroyed and with that the whole database destroyed. So don't forget to add persistent volumes for your data. And since we have both Python and Golang in our repositories, we also decided to copy the toy app written in Python in Go, just so we have a good sense of how the libraries work in both environments. And this was basically a carbon copy of the Python app, so not much to say about it, but the Clickhouse libraries were quite straightforward in both the languages. Regarding the Go app, there's a few things I wanted to highlight. So to begin with, we're using the official Clickhouse Go driver. And there are two ways to connect: the standard way and the so-called native way. So the standard way, using this function, but we could also use SQL open. Just create a standard SQL connection, which is quite nice because first it's standard library, and second because if we ever want to replace Clickhouse in the future, we don't have to replace the whole code base, we can just replace this part. And the other bits that depend on this SQL connection can pretty much stay as is. So this is how we insert a new row. One risk here is that these parameters have to be in the right order. What I mean is that if we have two parameters at the same time, for example, and we accidentally mix it up, it will be just saved to the database as is. So there's a risk of human error here. On the other hand, with the native connector, which uses this function and creates a driver connection, we can use the append struct function, which we can provide our struct, and it will be marshaled into a database insert statement. One thing that's good to know with this append struct is we can use the ch struct tag to define how the fields will be named in the actual insert. Because without this will be saved as capital D, capital S, capital L. But this is not how we want to save our database entries. Instead, we want to use snake case. So all we have to do is provide this ch tag, and it will be saved in the right format.
Circling back to the persistent volume problem, there is one other caveat here as when you're working into ClickHouse. If you, as we did, set up your table engine as an in-memory table, it will not be persisted to disk, and your persistent volume will not help you. We did it so you don't have to now. Learn from
the hard way.
Say again?
We found it out the hard way.
Yes, learn from our mistakes.
All right. So this is pretty much how far we got with the POC. We also updated some data we had lying around. So that was 1.5 gigabytes of data, almost 130,000 entries. And we could upload it in 5 to 10 seconds. So we can say that it's quite an efficient engine. What we didn't implement in the POC, or things that we want to maybe come back to in the future, one thing was the ClickHouse backup. There's a great library. The more we looked into it, the more complicated it seemed, and we realized this is not necessary for this MVC. So for now, we decided to implement a much simpler solution for backups and circle back to this problem in the future.
A couple of things we did not do in the POC was any sort of detailed secret management. As you look through our repository, you'll notice that the secret for the POC database is currently directly in code. Obviously not an optimal solution. We also looked at user management and thought that was a problem worth solving at some point, but does not have to be solved right away for this sort of demonstration capabilities, as the alternity operator does do a lot of that for you. However, it does it in a very static way, so we may have to address that in future. We also looked at various proxy solutions for balancing load across multiple clusters and across multiple insertions, which again is not part of the POC, but is worth looking at. Some of those proxy solutions also allow for more granular user management, so we will be circling back to take a look at those in future. So yeah, key takeaways. We had a wonderful time doing this. ClickHouse is an incredibly powerful system. We were not quite aware of how many different options they are, and we were not fully able to traverse all the way down all of the options. Truly impressive system that we were happy to build up a basic ClickHouse instance, get two sort of very chatty random data generating services up and running, and get a visualization going in Grafana. Much of what we've done here can be lifted. There is still, as we mentioned earlier, things around secrets, users, config control and stuff that sort of bridges between ClickHouse specific things and Kubernetes specific things that I think other teams would want to take on board if they were to take it at this stage. Or if you wait a little while, and we'll probably hammer those out in our next iteration. So there is one sort of caveat when you're dealing with data insertion using an atomic database engine. If you're not familiar with the difference between a database engine and a table engine is, there's a doc in our docs that links mostly to the ClickHouse docs. So you can go directly there for that or read ours. When you're dealing with an atomic database engine, you have to set insert limits. The initial theory is that you should, or the initial thought perhaps, is that you might want to set that limit as high as possible so you can insert as much data as quickly as possible. There are also drawbacks to that because ClickHouse internally will have to be inserting and sorting up this data. So you want to keep that within a relatively optimal margin for your insert period and otherwise, or your insert period and also the batch sizes, avoiding dropping and avoiding issues and avoiding really lagging out ClickHouse. So there are some limitations to atomic engines. There are definitely some guarantees in that you have atomic transactional guarantees on inserts, on database renames, or sorry, table renames, and several other things. So there's trade-offs there. Read the docs, be mindful. Juxtaposing atomic engines versus ordinary engines for the database as a database engine, there is advantages to using an ordinary engine. Despite the fact you don't get the atomic guarantees, you get higher insert volumes and faster inserts. So if you're just uploading a bulk bit of data and want to do some work, as was the case when we were loading some of the V2 model data, you can load faster on an ordinary table, but without set atomic guarantees. So again, choose your weapon and be mindful.